Sound check. Desktop audio. I don't think it's going through. I think I muted it. I think it's okay. I think it's fine. Okay. Good. So hi everyone. After a year or two, finally I decided to do another Blender tutorial, and this time we're gonna go through some sort of new feature. Not really that new because Blender is in 4 now, and this feature comes out when it was Blender 3. But we haven't touched on that, so I'm gonna talk about geometry node, scripting, and how we can use Blender to play around with point cloud data. Um, the material, it's gonna be online. So this node that I have, it's not completed yet. I'm gonna take my time. Recently, I've been very busy, so I'm gonna take my time to make this up, like finish this node. But hopefully, the video itself will be enough to walk you through step by step how to play with a point cloud data set in Blender. Um, and the tutorial itself, like the material that you'll need, it's gonna be on this repository, the same repository that we had before, but it's under another folder. I think these are the tutorial before, and this is gonna be the new folder. So Quixote is the one that we're gonna have. There's a couple of things. Blender script is the one that we're gonna copy and paste into Blender scripting interface. CoBlender data is the script that I used to generate like the data that we're gonna import into Blender, and Quixote Blend is basically final product of what we're gonna build today, and it looks something like this. So this is the data set. It's cosmological data set. If I can make it actually a little bit darker. Cosmological data set that has a bunch of halo tracer, which are highlighted at these strip thing, that hopefully will use it to mark the velocity field. And the balls are void that is found in the simulation that has different size. So this will be the final product. Like this surface means nothing. It's just there to like make like some sense of 3D-ness into this tutorial. If people want to have exactly the node that used for shading, this shader is actually pretty simple. But we're gonna make use of like geometry node a lot, and it's basically the same node interface that we had before. If people wanna like just copy and paste and play around with these things, yeah, feel free to check out the Blender file on the repository. I believe all the data here is actually baked into that file, so you don't actually, if you open that particular final product, you don't even need to download the data and import it. But anyway, we're gonna start from scratch, and we're gonna go from there so that you can follow through step by step. So the input, I believe, like in the last tutorial, I have some basic navigation instruction. So we're not gonna go through those. But like because some of them we will have some new viewer. Hopefully, that's the idea. I'm gonna say very explicitly each click. What am I doing? Like for example, I'll be like hitting middle mouse, scrolly wheel, and I'm like dragging around stuff like that. Yeah, so that's the battle plan. So let's get started. Cut this again. Okay, so if you downloaded Blender, so the current Blender version that I use is 4.0, but I believe at this time actually 4.1 is out, so you can use that. But when you open Blender, you see some splash screen like this. For what it's worth, we'll do general to start up like a new environment, a new project. Once you click general, you should see a cube in the middle. And if you drag the scrolly wheel around, you can rotate around. And there's nothing around it. There's the camera here. There's the light here. And because we don't need the cube, I'm gonna delete the cube by hitting X and hit delete. So that it's gone now. The path to the data set will be in the menu, and I'll link it. Even though before I complete it, I'll still link it in the description of the video so that people can play around with the data set. But I encourage people to really bring their own data set and have fun with it, because in the end of the day, we want to visualize something that's relevant for whatever we do, right? So once you have deleted the cube, let's go to the top tab and go to all the way to the right to find scripting and hit scripting. And this will bring up a couple of things. And here is a text editor. That is a Python text editor. If I hit new, and you can see this is a text editor, I can do import numpy, spell a equal to 1, b equal to 2, print a plus 3. I don't think this will actually print anything where we can see, but let's do it. So if I hit this play button after I push in this thing, it will say, oh, you have completed the script. So, and there is a terminal here that again you can import numpy. And by the way, this thing Blender now actually come with OpenVDB with it, so you can actually import PyOpenVDB and do all the processing here. So you don't need to build your own VDB version for importing volume data. So that's quite nice. Anyway, so to import the data that we into Blender, we need to go to the repository, open Blender script.py, and let's go ahead and copy and paste everything that is on here into the Blender text editor. We're gonna go through this a little bit later, but for now, basically one thing that we need to change is the path to the data set. And do I have it? No, I do not have it. So it's here. I'm gonna copy to the path. And if you're a Windows user on Blender, I believe some characters will give you some trouble. So if I do this, okay. So once I paste this script in, change the path to point to the data that I have, and I hit, you can see the black cube here. That is actually a cluster of point will be in front of you. Okay, by the way, I just did a center at object right there. I click on the object, hit tilde, and I do view select. That's view select. So let's look at the data that we just imported. So these are all the halos particle in our data file. I think there's a couple 100K of them. And there are the void particle, way fewer. Okay, but they're not very interesting in this sense because they're just dot, and it's not very interesting to look at. So we're gonna make them more interesting right now. Okay, so that is the scripting, and let's just go through the idea of the script. So basically, import your data. These are all just NumPy for people who are familiar with Python. And one thing that we need to make use of is this math-util thing, which I think it comes with Python. And we'll make a list that call vertices. And basically, this bunch of code is to create the object called Halo. So it's this guy. We declare some mesh data, so we create some. Say that this guy is a mesh. And so the position of the point, it's imported from this bit. So you basically describing how your mesh data. This linking is a little bit specific, so don't mind them. But basically your position is given here. But having position itself is not very interesting, and we can actually attach more attribute to. This will be more clear later on. That what I mean by attribute. But basically, we have the velocity field, and for each of the point, we also link the 3 velocity to the object, to every point. And we did the same for the void. And well, this code is actually pretty general. You can change these. Basically, this is your name, and this is the field that we get from the data, and you can change them around to adjust for your own data set. Okay. So this is the basic scripting interface. Like for people who are familiar with Python, this is really just using Python. The main dish of today is actually on playing with geometry nodes. Okay. I may switch between this and my nodes, or like my old my example to see to check the node tree, but that gives you more room to follow. That's good. Space things out. So now we are looking at the geometry data. So basically every object in Blender can be treated as like a geometrical object that can have different properties. For example, we just created like a mesh that has 4,000k vertices, which the vertices is basically the location of our halo. And they can have edges, face, corner, and stuff like that. There are different. There are other kind of geometries such as like curve, point cloud. We're not gonna use point cloud directly because there's less operation that you can do on point cloud. And volume is something that we used before, and instances which will be relevant later. But anyway, so let's go to, if you hit vertex, here is basically a spreadsheet showing all the data that is relevant for this halo object. So you can see the position here and like the attributes here, and there's like 40. Right? Okay. Wait, what is this guy doing? Damn. I didn't know there's a pointer. So actually we're gonna animate the halo later. We're gonna deal with the void first because that's easier. So once we're at this geometry nodes interface, you select the void. So if you go to the right hand side in this like collection panel, you can hide something in the viewport by clicking on the eye. So we're only showing the halo particle now. Okay. So once you're at this interface, come to here, click new, and this is the basic of the geometry node. So this is saying that like take whatever data in this void data set and render it or put it into the viewport. If I take this off, it's not there, right? Okay, so that's the idea. The first thing that we're gonna do is, because these are void, I kind of want to treat them as like sphere. So what I'm gonna do is to do instance. So hit like when your cursor is here, hit Shift A to bring up the add menu to add a node, and go to search and go to instant on point. Yes, that's right. Okay, so if you drop this, hold this guy, hold this new node, and put it on top of the line, you see it get turned white, and put it there, will connect, basically connect this node. And for the newcomer, basically this node is kind of like a function. You can give it all this input, and it will output like whatever that's supposed to do. Okay, and this is to say, you can read it from the name, that I'm gonna put the instance of something onto the point. And what is the instant? Instant is basically, you can see now, instead of having like a mesh of like 3k vertices, we have 3k instances. And you can see, oh, like there's like this new geometry. Instances is basically whatever object that we have rendered or created. And if I like make a pufferfish, let's say, and to plug them into here, then basically I'll turn every point that I just have in the void data set into a pufferfish. And that's exactly what we're gonna do. Not pufferfish, but we're gonna make a sphere. So go to Shift A to add a node again, and I think I need to have a UV sphere. Or you can go to add geometry. Mesh primitive. You have all these different primitives. We have cone, you got a cube. We're gonna use like UV sphere, which is the type of the sphere. And if I connect the mesh into instance, and suddenly we have all the sphere. Okay, so if I drag the radius around, you can see having like a bunch of sphere. I can make them even smaller. So now our void data set becomes a collection of sphere. Well, it's not that deep. It's pretty simple, isn't it? So there's that. Now, but there's one thing that is missing here is the size of the void. Now, every void particle has the same size, which is not exactly what our data is. If we look at our data again, you can see there's a radius that we imported. And we want to make use of that radius in this situation. So let's go ahead and plug that back in. And now you may be tempted to use the radius here. But one thing that I learned fairly recently about input and output is, so when this point is a circle, it means that it takes only a scalar, like a float, a number, as an input. Unfortunately, like geometry node, actually, like the radius is not so much a scalar that it's universal for every point, and that would be pretty boring anyway. It's a vector. So if it is like a rhombus like this, that means that it can take a vector field as an input or as an output. If I try to, let's say, so she's shift A, and actually I'll do attribute, attribute, no, input, sorry. Yes. Wait. Named attribute. Geometry read. It's actually here. Anyway. So this is a way for me to name attribute. It's under the geometry read menu. So you can retrieve information related to the geometry here. And so we can get radius here. Select radius, which you're gonna basically this node will fetch all the radius of our geometry data. And you see this attribute is a vector field. So if I plug this in, it'll turn red and it'll bugs out. So it doesn't like that. And instead of like doing this, what we need to use is like this scale output. So what I'm gonna do is to combine X, Y, Z. So this node, like Shift A, and do combine X, Y, Z. Plug this guy in. So this is a XYZ is equal to the radius, and plug this in. Now you may think, oh, there's nothing here, but actually, just because the radius is very small and you're getting like the norm of it, that what makes it small. But actually, we can scale. Add a node called math. To multiply. Let's say 10. Okay. So now you can see there are some sphere that is bigger and some sphere that are smaller. All right. So there you go. That is some way to make use of the geometry data. Okay. And so far this is fairly straightforward. But one thing that is pretty powerful that I found about a geometry node is it not only can deal with like shade, like attribute like this, it also has indices. So what I want to do is now the void cloud here is fairly monotonic. I mean, they're all white. It's not very interesting to look at. And if I go to render field, they all look white. So that's not very interesting. And what I want to do is basically I want to add color, like a random color to this voice, so they're a little bit more like distinguished from each other. And to do this, we'll do the following. And basically, instead of but like I mean, we don't have a field called color. So all I'm gonna make use of is use of the index. And what you can do is to add a node, Shift A to add a node, and do index. So same as the name attribute that read off the radius, this will basically get the index of the node, like of the geometry. And now let me read my cheat sheet. How do I do this? So like these are like basically the complete node that you can also go to the node, like nodes that I have, and just check it. Okay, capture attribute. Okay. Yeah, sounds about right. Okay, good. All right. So bear with me. There's some magics that we're gonna do here. So what we're gonna do is to capture an attribute. That is to basically, we can not only output the geometry, but we'll also output the attribute of something. So if I do this, this is to say, I'll take the geometry. So when I add this, I just do Shift A. Shift A is always how you add a node. I'm not going to repeat that too much, but then I search capture attribute. Okay. I'll get this geometry. From this geometry, extract the index of this geometry. And now the geometry is not being processed, so you can plug it into whatever it is. But one thing that we're going to do in addition to that, like, is to output this index. And we can name this. Now I'm outputting this index such that I can use it later. And this will be important later. Okay. All right. So this is how you set up the capture attribute part. So to render this to have color, I'm gonna do what's that called? Instance. Realize instance. So that's one thing that we need to do. Basically, I'll actually make all the instance. So before I do this, let's examine the spreadsheet. These are all hold as instant. So this is actually more memory efficient because you're not actually making them into actual vertices. It's just saying, oh, I have this UV sphere that it's, cached somewhere. And you can put them on the point. But once I put this realize instant node onto the green line, you can see like instances is no longer here. They all been turned into like meshes. Okay, so it has faces, it's edges, and it's like radius, which is a single number, but it doesn't matter. So because these vertices correspond to like basically the same sphere because like they have the same radius. You can see only if I scroll far enough, the radius start changing. Okay, that doesn't matter too much, but that's the logic behind it. And what we need to do is to set the material of this instance. So you Shift A, set material, and there you go, you bring this up. We don't have any material yet, so we're gonna make it now. So you can't see anything here yet. But let's go ahead and do the shading tab to trying to make the make like a material so that we can see some color of this. So we'll go to the shading tab, hit new, and you can see this brings up the principal BSDF like shader. This is to say make all surface white basically, which is not very interesting to look at. Now we're gonna go to look at the texture. Yeah, it looks like this. So I'm gonna like the same way that you use a geometry node applies here. So we're gonna do Shift A, attribute, and click here. One thing that I forget to do is, so we outputted this attribute so that we can use it, and we actually need to capture it somewhere. So if you go to this panel, hit this like right arrow, and you can actually rename these things. So let's call this guy index. Okay. And now it becomes index. Do I need to click this? I need to click this. Let's see. I don't think I need to change. Let me just quickly output. I think that is good. I think that's good. Okay. So change this to index. And now let's go back to the shading and put index here. Let's hope this works. So this is basically saying, okay, from this geometry, capture the attribute that's called index, which is what we just output. And then I'm gonna add a white noise texture into color. Oh, that does nothing. That still does nothing. Do this. Interesting. Am I not outputting this correctly? Oh. Oh, I see, I see. Because I didn't set the material. Okay, I'm gonna go explain this a little bit. So we have this attribute that we capture the indexes of this thing, and we plugged in the color. We plugged in the color into this white noise thing. Well, actually, something that didn't sit right for me. Bear with me for a second. What is going on? Point geometry index output. Let's see. Streaming is pretty good in this, so that I don't need to edit it. I can just fumble in people. Maybe I need to output it somewhere here. Index. Output. That's good. Let's see, what's this guy doing? Point. Material. Let's see, geometry, floats, point, realize instance, material. I will line up the time instant and clip that out so that you guys don't need to suffer through percentage attribute floats. I think let's read this off actually. Material index. Oh, what about this? I think I'm missing something. I do this. Snap. Didn't do it. Missing something. Radius value index. Looks right to me. It just have to go into the nodes, I guess. Strength. Index. Spelling mistake. Serial index. What's this guy doing? Wait, no. I think geometry is fine. So if I do this, what does that do? No instant yet. That's it. Float point. That looks okay to me. Why? 1 second. This is why. Uh, this is why I have the reference, so I can open it. I'm pretty sure it's like something like here. Index. Oh, okay, fine. I know what's going on. Tutorial. So we're gonna that work. There we go. Okay. All right, I can explain what's going on. So the hiccup was, I outputted this thing called index, but I didn't name it, like so it couldn't capture it, like elsewhere. So this is to say, oh, okay, like you have this geometry node that want to output an attribute called index, but I didn't give it a name, so it doesn't know what to do, and I cannot refer to it elsewhere. So once I added the name in, now the node can correctly capture the index, and this snap is just to basically change how frequent, like binning it. It's basically binning it in like a histogram. If I do like a smaller increment, I'm like narrowing the bin so you see like more color. And like in so to make this a little bit easier to distinguish them, we're gonna add a color ramp. Well, this goes way longer than that. And I'm gonna turn this into constant. And I'm gonna add another marker here. I'm gonna turn them all into like RGB basically. That looks ugly, but that's okay. So if you click on the marker here and click on the color, rectangle on the color palette, now tada, we have like a RGB ugly looking okay. So in the same vein, I'm gonna go color the halos. Okay. So we did the part related to the void particle. Okay. And now I'm gonna do the halo part, which is way more particle. So we're gonna do the same thing of like creating a geometry node. And well, actually, what I can do to copy. Oh no. Oh no. It's too many things. So what I just did is trying to like apply basically the geometry node of what we just did for the sphere onto this way more abundant halo data, and it's having a rough time. You know, there's like 100 times more stuff to apply to and to render on. So it might be having a stroke. So don't do this. I shouldn't have clicked that button. If it like, oh no. Go on. We might have also hit save often. I think I did save in the tutorial earlier because I want to like bring up the other one, look at, so we're not too far away. But I might have to kill this one. I'm gonna wait for like 10 more seconds. If it doesn't finish in 10 more seconds, it's not gonna finish in the next 2 years. Gonna drink some water, I guess. All right, time to go, buddy. Unfortunate. What is Xbox Online? Banner. serve me well. Oh my god. Not even. No! The house manager! Oh! It's gone. Alright. We're back. We're good, we're good. I can speed run through that bit. I feel like I can. Yeah. So this is that. Not outputting this. I'm gonna do that. Add the color. Oh shit. The color RAM. Oh my god. No, please. There we go. Oh. Change the color. Oh, change the mode into constant as well. What the? Oh, this guy. Guy. And this guy. Very good. Oh. Okay, that's good. Where were we? Halo. Save. Okay. We're gonna create. Oh well. Let's copy these node. That's actually a bad idea as well. Now I think about it. I'm gonna copy the top half and paste it there. Alright, screw you. Actually, they just roll from the beginning. So I'm gonna add a point instance on point. Okay, so now they're all gone. And what am I gonna do? Because like there's a lot of different point on this geometry. Instead of showing all of them, I'm gonna filter them. So what I'm gonna do is I'm gonna filter the index. So what I just did there is I get the index node, Shift A index, and I bring up a map node and choose less than. Okay. And how does the node look like for okay. So I can plug this into selection. So before I plug it in, you can see there's like 4,000 instant. I mean 400,000 instant. So that's quite a lot. And if I plug that in, it'll only keep the first 1,000 of them. So that's way more manageable. Okay. And now I'm gonna add a primitive that is cone and plug it into instance. Now you can see all of our halo becomes a cone, like this majestic cone. But that's too big, so let's make them smaller. Become this like chopstick kind of thing. Okay, so now we have our cone. That looks like that, which is pretty wacky, but it's also kind of fun. Okay, so if I make the radius smaller, oh, that's not what I want. I want the opposite. Got. How about this? I can decrease the vertex into like 3. Should be good. So this is like tetrahedron. Maybe even smaller. This? Okay. So I guess it's like really, it's a little bit too small, isn't it? Alright, that sounds about right to me. And so basically, instead of turning each of the halo particle into a sphere, we turn it into like this pointy arrow stuff. Now, we're gonna make use of this rotational thing, just like how we did with the radius. You can collapse the node by hitting this button. So they're a little bit more tidy instead of like mess. So we want to make use of the velocity as like our rotation. So what we need to do is basically get the name attribute, get the Vx, and if I hit Shift D, I can duplicate this guy, do again, and basically get all three components of the velocity, combine X, Y, Z, and now, oh my god, please no. Now I have a vector that describe basically is these three columns in my data. Okay. And if I plug that in, it will do something. But you can see it seems suspiciously aligned in the Z direction. And that's because like these are not rotation. These are velocity. So what we really want is like some Euler angle. Now, as of making this video, I actually have not completely understood how to do this. Like instead of doing the real math and figuring out the angle, which will be a hassle in Blender, I'm just gonna hack it a little bit. Is this Euler angle? That's not right. What's the node I use? Oh, I just plugged it in. God damn, that was brutal. What was I using? No, this is not the one. Vector. Align. Rotate. Vector rotate. What does this do? Center. Maybe? Right. Still looks suspiciously aligned with the north. Okay, now this one. Rotate to Euler. Line Euler. I used to use this, I think. Pivot. Oh wait, this is pretty sick. What? Oh. Wait. Does this look somewhat normal? Alright, maybe the resolution is a little bit low. Let's do 5,000. Let's see where the hell that go. Hey, that looks pretty random to me. Hey, I claim victory here. Okay. Well, yeah. That looks pretty random to me. Is it? Well, I'm sure people who are more patient than I can go figure this out. But the point is, we're gonna like take the velocity field and make them a vector and try to use it to rotate. Does it? Wow. Okay. To rotate the cone such that like it can kind of like act as like a velocity field thing. Actually, let's increase the number to let's say 9,000. All right. How does that look? Looks atrocious. Because it's too big. We're gonna make this shorter. We're gonna make the halo particle shorter. That it is. Vector math. If I do Shift A vector math, oops, multiply. Scale 0.5. Let's say. Does that make it like nicer? No. Okay. 1. Wait, it's not doing anything. What the? Oh, I was an idiot. You come here. Boom. That's too small. That's still too small. 8. Wow, that's really small. Well, I'm just scaling the vector here. Now that is too big. Is there preferred direction? It seems like there's a preferred direction, but if I don't scale it, it looks more random, isn't it? Oh, maybe because I'm scaling. Oh, that makes sense. So if I further scale the XYZ, right. Okay, then. Can just do this. That is not a good idea. 1, 1, 1. And we'll do 0.1. Oh god, that's not good. 0.1. Oh, that's not good. 0.9. Okay. Hey, that looks pretty good. Maybe a little bit too much, but we'll adjust that later. Anyway, oh, sorry for like the detour, but I'm just like playing around. Wow, this actually looks pretty cool. Not gonna lie. You can see some void here and there when you rotate around the angle. Anyway, so the idea is like to use the velocity field to like randomly rotate. Not randomly, but align the particle along the velocity field. Okay. So far there's like basically the same concept that we have used in same concept that we have learned in making the void data. Now, one thing that we're gonna do slightly differently here is we're still gonna do realize and choose the material. But oh my god, set material. But instead of color coding this guy based on the index again, which I guess in this case you can actually, well, actually no, you cannot do it because like the number of halo particle is not the same as the number of void particle here. But what we want to color is basically I want to color the halo particle according to the closest void particle. So if like the closest void particle is blue, I want to make it blue. If the closest particle is red, I want to make it red. So how do I do it? That's a good question. Let's look at the halo node. Okay. So what I'm gonna do is Shift A, add a node to call object info. So this will basically pull up the information from an object, and it doesn't have to be itself. And this is what makes geometry node so powerful, is I can pull in other information as well. So I'm gonna choose void, so that I have that's good, and I do sample nearest. Okay, so if I plug this in, like, so I'm gonna say sample the nearest, is that index? No, position. So what this does is like saying that given the position of my halo particle, I will go to this object called void and sample the nearest index. So I'll take the first position. Let's say I have halo. This is like this position. I'll find the nearest void particle, the index of the nearest void particle. Okay. So can I do it? No, I don't have that. Now if I store that, I can now store that into something called index. Okay. No, does not apply. And I'll plug this in. Right, that's good. Okay. Where's oh, I don't actually need to realize the instance. So now I'm gonna plug this in. Okay. Does it have index? It doesn't have index. What the hell? probably doesn't matter. Now we just need to create another material for this particular table thing. So I'm gonna kind of copy this, but there's a twist to this. So I'm gonna go to the old material that we use, copy that, and paste it here. Okay, that's a lot. Oh. Kill this guy, kill that guy. But one thing that I believe we need to do is do instance here. And that does nothing. Oh. Index. Good enough. Void. Oh, maybe I'll need to do like duplicate it. Oh, wait. Whoa. That's a lot. Let's see. I remember I need to duplicate this guy, so let's go ahead and do it. Why do I need to do that actually? I believe. Ooh. See, where's the logic? I'll just clip this out. That's easy. Void 001. So here. Sample index. Store name attribute. Why are they all blue? Do I do geometry? What does that do? They're all red. But oh, hey. I think it's okay. So what this does now is based on it's actually a piece of racket. Based on every index of the geometry itself and color coding it. So this is just 0, I believe. This is gonna go wacky again. Instance. This guy currently does not have. God, my computer is going haywire. So do index. And if I do this, does nothing. Brilliant. If I do this, check this out. Nothing. God damn it. Wait. So I take the instance, I store a name called index onto this geometry. So the geometry should have an index now. So geometry, this. Oh, I see. I see what I did. I remember something like this. Regional. This one. Sample nearest. This guy. How about this? Shit. Uh. 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 Where's... Wait. Oh, I see. There we go. Aha. Now we're cooking. Good. There we go. Oh wow, this looks better than I did. Wait. Oh my god. Oh no. Fuck it up. Hey. Why are you blue now? Oh. Okay. This guy is out. Sir? Wait, am I crazy? No, 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 no. It's just like this looks like this. Looks better. Hey! Not too shabby. Okay. Hey, I'm not crazy. Maybe a little bit. Hey, that looks all right. Okay. Whoa, I got carried away. Sorry. Um. So basically, what was missing? I was a little bit too much in my brain for a second. So what was happening is this void. So that index wasn't there, and that was because I think we were storing the name attribute in the wrong part. I think we were having like point, and that you can see I was like trying to debug here. There's no column called index here, so we couldn't pass that to the material. So instead, we store the name attribute in the instance uh, uh, part of the geometry, and now it can pass the correct index into the shader, which now use the index from the instance to render the texture. Hey, I think this actually looks better than the reference. I may upload a new reference. If I go to, so this is basically all the coloring and the node and this and that. And it's very disorienting now, but that's good. That's what we want. Well, not always, but I think the coloring and orientation is actually more coherent in this one. Yeah, I think so. But this is all the node manipulation that you hear. I didn't realize it's already an hour. This is a long tutorial, very long tutorial. And you can see what I'm trying to do is I want to zoom in into. Oh my god! I want to zoom in into one of the void. So let's do this. Go in. Go in. I don't think I need Eevee for rendering. Oh, Jesus Christ. A GPU for rendering. Oop. Oh wait, can I zoom in? One of them. I just need. Oh. Um. Let's see if the color. It's a little bit hard to like navigate in this like mumbo jumbo like large scale cosmology thing. But yeah, you can kind of see there's not a lot of well, there's a lot of odd color, but this is good. Like when things are close to each other, the halo are kind of following the color. Let's see. Get this guy. Oh my god. The halo, it's well, that actually doesn't make sense. Well, I mean, there's like some small halo part, like a void particle somewhere. It must be. Well, I didn't claim this to be completely correct. I just claimed this to be cool. It does look somewhat cool. Anyway, so that's how you manipulate the node and pass information from one object to another. Maybe the index is a little bit off. The index is probably. Oh, right. This is okay. So the reason why the color is off is probably because it's indexing using the entire Halo. Yeah. Well. Huh, Anyway, we can be precise, and we all know math here, so we can go in and figure things out. I believe. I think there's some mistake here and there. So make this look a little bit wacky. But so that's it. The shading is relatively straightforward. The geometry, passing the data around could be a little bit like a tricky from here to there. But there you have it. There you have like how to manipulate point cloud data and shade them according to some of the properties of the point cloud. So to end this tutorial, what I'm gonna do, it's actually like what I did before. Then I'm gonna add a plane, Shift A, your best friend, and I'm gonna press G, X to move it in this way. And now I think if you have Y, yeah, it casts a shadow on it. It looks a little bit wacky. It looks very wacky. Oh shit, where am I? Did I hide it? That's also a mistake. Where's the shadow? Hey, there's my shadow. And if I place a to place a camera and do a render, how long this will take? It's probably take a while. Oh wow, that's actually pretty bad. So I'm like casting a shadow onto a plane. So if you want to render, press F12 or well, this is rendering. There's a render image there. And to place your camera where you're looking, to control alternate 0 on the keyboard, and you can put your camera down. Hey, that looks pretty sick. Hey, I think that looks pretty cute. I think that looks pretty cute. Oh, who am I kidding with? This actually looks a little bit wacky. Anyway, so there you go. This is the tutorial. There's I may clip out some of the middle that I fumble, or at least I'll timestamp it where you can like just jump around with the timestamp, so it's not like too. But like if you want like the full Blender experience, that there's it's kind of like programming that you have like some debugging session is figure out okay why the logic doesn't work. I'm actually gonna save this. Looks cuter than the one that I made available. And yeah, so be creative and do whatever. Like this is kind of like creative programming. There you go. All right. Thanks for watching. If you stay until the end, I will see you next time.